some displacement reactions. Displacement reactions are where we take a metal and react it with a metal salt, and if this metal is more reactive, then it's going to take the salt away from the other metal. And we're going to start this by having a look at the reaction of magnesium with copper sulfate and see what happens here. So let's go over and have a look and see what happens when we do this. Well, I'm basically ready here with my spill tray, because this could be a little bit messy. And what I'm going to react is, I've got some copper sulfate. I've got a couple of solutions. I've got either a 1 molar or a 0.1 molar solution, and I've got to go with that some magnesium, and we're going to have a little look at this reaction. So what I want is a small beaker, and we'll have a look and see what goes on in this reaction. We'll go for a small beaker, and let's put that out the way. And yep, I'm just going to go for a 50ml beaker, and we're going to have a look at copper sulfate. Now I've got two solutions here, a strong one and a weaker one, and I want to see what's going to basically go on. And I think we'll try the strong solution first to see if that's going to, you can see something happening. I'm a little bit worried it might not see really enough that's going on. So let's take a small amount of copper sulfate. Now copper sulfate, not particularly nice. I brought it out to have a look at, and it's got all sorts of nasty labels on it of saying it's particularly toxic and horrible. So I think before we do anything else, we'll put the safety specs on for this one. So there we are, ready to have a go at playing around with this experiment. So I want a small amount of copper sulfate, and when I said a small amount, I did mean a small amount here. So we've got our copper sulfate, a small amount, and I want to try and see what happens when oh dear, I get some magnesium turnings with this. So let's take a few magnesium turnings and we'll put them in, and we'll see what's going to happen. And we can see immediately there is some sort of reaction going here. We can see that there is some sort of change going on. What I'm going to do is just get out a stirring rod, and I'm going to give this a little mix. Now what do I notice going on? There is a slight change in temperature. We're seeing a colour change going ahead, that we've got the strong blue colour is definitely sort of disappearing here. And we've got some sort of reaction gone on. Now how can I tell more what's gone on here? What can we do to try and identify this? Well, it is possible to have a look and see what's gone on if we just perhaps filter this. So if I get out a filter funnel and a piece of filter paper, then what I'm just going to do is I'm just going to take a little bit of this and have a look. Now my filter paper I'm just going to fold up. I'm just going to do a quick and dirty system here, just fold it in quarters and then just take one of those quarters. I'm not after an enormous amount of stuff. As you see, I've only got a small filter paper in there. I'm not going to use a whole lot. I've only got a tiny little bit of liquid, and I'm only going to put it into a very small little beaker, just so we've got some idea of what's happening. So let's take this and put a little bit in there, and let's see what happens. I'm hoping that that is going to filter out reasonably quickly for me. I'll try to well, I'm getting some bluish solution down here. It is still quite blue. So I haven't got rid of all my copper sulfate. I've still got some copper sulfate in there, and my magnesium. It's certainly lighter than it was. It's a much lighter blue. So maybe my magnesium hasn't completely reacted with this. I was hopeful it was going to go and be a bit more reactive than that. I'll put it back in here. I was hopeful that when I have a look at some of this, we might have seen we've got some sort of colour change going on here, but it's not quite what I'm after. So I'm a bit disappointed with that experiment. It didn't work terribly nicely. I can try it again, and I'm going to use less this time copper sulfate solution, and I've got a 0.1 molar solution. And there's simply less magnesium there, less copper there for the magnesium to react with. And I'm going to give it a mix. Well, something is happening. It's going sort of a bit cloudier. I think it's gone clearer than it was, which is what we saw last time. The blue solution got less. And it's going a little bit clearer. What I was hoping I'm going to get is a much clearer sort of solution, and I think in time that is going to go a little bit clearer for me so I can see what's going on. But at the moment, looking down here, it still looks quite blue, so I'm not getting an awful lot of reaction here with my magnesium reacting with my copper sulfate, and I was hoping that that was going to work better. Okay, so we've looked at a reaction of magnesium with copper sulfate. Let's have a look and see what the reaction. So what I was hoping that we were going to get is, if we look at this, I'm going to get magnesium metal, let's zoom in a bit, plus copper sulfate is going to give me magnesium sulfate plus some copper. What I was hoping was that I might be able to see the orangey brown colour of the copper appearing. The copper, which is blue, going to clear of magnesium sulfate. And I will see that, but I've got to leave it a little bit longer just so I can see what's happening. So if I want to look at this, we can look at this as an ionic equation. Now we can see that the sulfate is there before and after, so it's not really doing much. So let's look at this as an ionic reaction. I've got some magnesium metal, it's a solid here, and this is going to react with some copper. Now these are copper ions here, so these are also now dissolved in water and they're copper 2+. Now a metal is neutral, so we know it's got a charge of 0 on it. And this reacts to give me magnesium sulfate, where the magnesium here has become an ion and the copper, that's also aqueous, has become an atom and solid. I haven't bothered to draw the sulfate in.
Solid to your shopping list. By the way,
Alexa, stop. So nice to have help these days. The sulfate here is not taking really part in the reaction. It was there before, it's there after, it hasn't changed. So we are seeing only here something happening with the ions of the metals. This is why it's called a displacement reaction, because the magnesium here is displacing the copper. And when we talk about these reactions, sometimes we use a special phrase which is OILRIG. And here oxidation is loss and reduction is gain. And this we're talking about of electrons. So let's have a look and see what's happening. The magnesium is going from 0 to 2+. When we look at something like magnesium, we know it has here the same number of protons, which are positive, and the same number of electrons, which we know are negative. We are here going from 0 to 2+. To do that, we've got to lose some electrons. So here magnesium is losing electrons. So we say that this is an oxidation, because it is the loss of electrons. Let's look at the copper. The copper is going from 2+ to copper metal 0. In this case, we've got our protons, which are positive, electrons negative. I've gained some more negatives here to make this 0. So this is a reduction is gain, this is a reduction. In most of these reactions, if you've got a reduction, you've got an oxidation. if you've got an oxidation, you've got a reduction. If something is losing electrons, something else must be gaining them. So we've got this balance, and you will find that when we do this sort of balance, here I am gaining here some electrons, and I'm losing some electrons. So the copper here is gaining 2 electrons, the magnesium is losing 2 electrons. They are balanced. When we look at a lot of these reactions, and we could look at perhaps another one, which is that of looking at something like zinc metal reacting with something like lead nitrate. Now, what might happen with this? Well, we need to try and see if we can see what happens. Now, trying to do this is relatively difficult because we want to see if we can get some lead crystals growing here, and we'll often do this on a piece of zinc foil. And here it's not very easy to see. It does seem to take quite a long time when I do this, and it doesn't seem to work terribly well. The idea is we have a test tube, we fill it up here with lead nitrate, and we put in a piece of zinc, and what we can see after a while are some crystals of lead growing on this piece of zinc. Now, I'm not going to do this because it takes too long. Instead, what I'm going to do is we're going to have a look at a few of these different reactions to see what's going on. Just as a little aside, I want to remind you that when we look at our reactivity series, we've got the most reactive metals like potassium, sodium, lithium at the top. In the middle, we've got metals like zinc and iron, and down the bottom we've got metals like copper. I'll shove an extra one in there, magnesium, because it's up there on the reactivity series. And we can see that we've got magnesium is higher than zinc, and zinc is higher than iron, and iron is higher than copper. So let's have a look and see what happens with a reaction of these with the different sulfates, and we should be able to work out what's going to happen from this. Now, let's just draw up a table of results before we start. And what I'm going to do is I'm going to react each of these metals with a salt. So we're going to have magnesium, I'm going to have zinc, I'm going to have iron, and I'm going to have copper, and I'm going to react those with magnesium sulfate, with zinc sulfate, with iron sulfate, and with copper sulfate. I think to make life better, I'm going to make this so I can draw in and put little ticks, and we can make some predictions before we do this experiment about which ones we think are going to work and which ones aren't. Before I even start, however, though, I'm not going to try magnesium with magnesium sulfate. That's not going to do anything. I'm not going to try zinc with zinc sulfate. I'm not going to try iron with iron sulfate. And I'm not going to try copper with copper sulfate. So that leaves us with these to try out. So let's go over and have a look and see how we're going to do this experiment. I've left this one a little while, and I think that we can see that this has gone certainly a little clearer than it was. If I hold that up with the copper, it's looking a little bit different in colour, especially if I look at the other one. I am now seeing a sort of a muddy colour of copper appearing. Paul will try and focus this for me. There we are. So we are now getting some copper and quite a muddy sort of solution there, but it's looking largely clear. So perhaps I was a little bit enthusiastic in having a go at that one too soon, because it's become clearer now. Right, so we're going to have a look at our solutions. I think it's probably going to be easier if I take a little bit of this one. This is magnesium sulfate. If you want to see some magnesium sulfate, there is magnesium sulfate. It is a white crystalline substance, and I've dissolved a small amount of that in some water. So I've got my magnesium sulfate. I haven't labelled it, and what I'm going to do is I'm going to react with that. I've got some copper, I've got some zinc, and I've got some iron. So I'm going to react each of those with this and see what happens. And this time we're going to try this on a spotting tile to see how well it might work. It might give us a better idea of how the reaction's going. Nothing goes easy. Right, okay, so I eventually got a pipette here, and let's take a little bit of this magnesium sulfate solution. I've written first 3. Put it out of the way, and let's try each of these. So first of all, let's do them in order that I've got them. So I'm going to do my zinc first, then I'm going to do my iron, then I'm going to do my copper. I only want a small amount of each of these, so I'll get out some spatulas, and I'm going to use the other end because I only want a tiny little bit of each. So let's take a small amount, perhaps that was a little bit too small, amount of zinc, and I'll put that in there. Nothing immediately obvious happening there. I'm not seeing any bubbles, changes of colour or anything else. let's try some iron. So here are some iron filings. No, nothing seems to be really happening here. And then I've got not copper filings, but I've got copper turnings. And let's see if we can just put those in there. And well, I don't seem to be seeing much happening here either. So if I want to try and record this reaction, it would seem that this is a little bit of a failure as it goes, that zinc reacting with magnesium sulfate doesn't seem to be doing anything, nor does the iron, nor does the copper. Now, from my predictions, I'm not that surprised with that, because magnesium is the most reactive of the substances, so I wouldn't expect much to happen. Let's look at the next set. And the next set we're going to have a look at is, I'm going to look at reacting zinc sulfate with magnesium, with iron and with copper. Let's see what that does. So let's have a go. I've got some zinc sulfate solution, and to go with my zinc sulfate I'll get out a clean pipette. And let's have a look at this. So zinc sulfate, again a nice clear solution. That pipette worked better than the other one. Put it over there with the other stuff. There we are, there's my zinc sulfate put away safely. I didn't show you zinc sulfate. I will quickly show you what zinc sulfate's like. Zinc sulfate comes with a nice friendly label on, say, other danger, and I wouldn't give this to any sort of plants or other people to sort of live on. And again, it looks, oops, wrong way, the same. This is just a white crystalline solid. I'll put it away, out the way safely, so we're ready to start. So the first substance I'm going to react with this one is going to be the magnesium. So let's take a small amount of magnesium, and let's see if anything happens. Now if we come in and have a look, well, I can see a little bit of something happening, but it could be more my imagination than anything else. But I think I can see something if I just get a little glass stirring rod. I think we've got a slight change in colour of the magnesium. Very slight. I'm not... Yeah, I think I can see some change here. I'm not certainly seeing any change in the colour of the liquid. But then, if I am reacting magnesium with the zinc sulfate, then if the magnesium's taking it away, then I'm going to get a solution which is like this, clear. So I am seeing a slight change in colour. Let's have a look and see what happens with the iron. I'm not going to do zinc with this because it's pointless. Let's try some iron with this. I'm not expecting to see much happening, and I don't think I'm going to be disappointed here. And then let's just take out a couple of little bits of copper and put them in, and I'm not expecting to see anything happening there, and it would appear that I'm not terribly going to be disappointed. So the magnesium, we've got a slight change of colour, not really what I'd call a reaction to write home about. This is why we did this one first, because I was expecting to see some colour change, and we did get some colour change, whereas this one, no. So I think we're going to write this one up that magnesium is reacting with the zinc. We've got some colour change, nothing apparent on the other two. So our next one is to look at the iron sulfates. Now we might see something more happening here, because iron sulfate, Paul just zooms in on this, iron sulfate here is a different colour, and this is iron sulfate. Iron sulfate is a greenish colour, and for anyone who takes iron tablets, they often take these tablets which are this sort of green colour. As well as iron 2 sulfate, which I've got here, we can get iron 3 sulfate. I'll leave that one out so you can compare the difference, and I just got some iron 3 sulfate out just so you could see the difference. So here is iron 3 sulfate, and we can see that there is a remarkable difference in the colour and a remarkable difference in the chemicals as well. So this one, very different, and I've chosen to do iron 2 sulfate for this experiment. I could have chosen iron 3. I believe iron 2 works better than iron 3, but it should work the same. So let's get out a little bit of this iron. And there is my slightly coloured iron solution. Now we're not going to react this with iron, so that one we're going to ignore, but we are going to react with magnesium, zinc and copper. Let's have a look and see what happens. So let's put in the magnesium, and we're looking here to see if we're getting any change. I'm not convinced as yet. If it is working, it's working fairly slowly. Not seeing really any desperate colour change. I think I might see a little bit, but again, that could be my imagination, or it could be the fact that I put the magnesium in there. Let's try some zinc with this and see if this has any effect. If anything's going to happen, I'm expecting the solution to change colour, and we'll have a look and see how they get on. I'm not seeing a lot there, but I'm not expecting it to change. Let's try a couple of bits of copper in here. And using the other end of the I've got to decide whether that's actually getting clearer, and I'm not totally convinced there. What do you think? Oh, we're zooming out, there we are. And then my last solution to try. So if I record my results, then we're not really looking at much happening here. I think we could have to say the jury's out on that one. It doesn't seem to be happening. I'm looking at the zinc. Might be. I'm not convinced anything's happening there. Copper, no change. So now let's look at copper sulfate with those. And I'm going to take my dilute solution of copper sulfate. And let's put in a little bit into each one. Gloss the lid. Right, my copper. Let's try and add a little bit of the magnesium. So, having confused myself which is the spatula for that, I'll get another one out. So let's try a little bit of magnesium with this, not trying too much. We're going to try zinc with this. And finally I'm going to try some iron with this. And again we're looking for any remarkable changes in colour, anything happening. Is this solution getting a little bit clearer rather than being blue? Is this one changing? And is the last one changing? Well, it might be a little bit less blue, but I'm not convinced. So the only ones that I'm going to give here, I can't see the copper, magnesium reacting with the copper, although we have done that one previously. The zinc, I don't know, I can't see anything, and I can't see anything with the iron. I'd like to have some more going on here, but I can't really see that it's really happening. Maybe that's less blue than it was. A way of telling is that if I take another spotting tile, and what I do with these spotting tiles is the only ones that we can really see working are the copper and the iron, because they're changing colour. So let me put a little spot of blue in here. Are we seeing, do you think, any difference in colour between this one and this one? I think there is a very slight difference. These seem to be the different colours as well, very slightly. As I am seeing a slight difference here. If we look at the iron, let's just compare the iron. So this is iron sulfate. And I'm just going to put a small amount of iron sulfate in this one to compare. Let's see what we've got. Well, I think looking at these two, and I can bring this round so we can see it, we have got a slight change of colour here. If anything, it's darker. No change there. And I'm not sure about that one. It really is difficult to tell. So let's take this back and have a look at what we've got. Having done this reaction, what I've got is these results. We've got nothing reacting with the magnesium sulfate. I couldn't see anything happening there. Maybe a slight change with the magnesium and the zinc, but that is a little bit more wishful thinking. We know that one did work, we've tried that one before, but watching it there, didn't seem to be that effective. With the iron sulfate, we should predict that this one should go, so I'm going to do these in a different colour because I am predicting that should go. Let me zoom in. I am predicting that that should go, that should go, and that should go. And I am predicting that the others won't go. And it's very difficult to see, looking at this, what's actually happening. I'm a little bit disappointed with that experiment, that I don't really see that we could see too much happening. It's not one of those that works really well. So looking at this displacement reaction of a metal and a sulfate, we're not seeing an awful lot happen. So let's finish by having a look at one that I know is going to work quite well. And we're going to look at, if I take a different sort of reaction this time, and not a metal with a salt, but I'm going to take something like here, this is going to be a metal halide. I'm going to take some potassium iodide and I'm going to react that with something like lead nitrate. And the potassium is more reactive than the lead, so I would predict that the potassium is going to form potassium nitrate. I didn't put the brackets in there. Plus what we're going to get is some lead iodide. Let's try this one and see whether or not something happens, because I'd like to finish with one that's going to work, and this one usually does. I am saying usually in science because we can't be sure it's going to work every time. Chemistry, I find, is a lot better than biology and physics. Physics things should work and usually something sticks. Biology, under conditions of constant temperature, humidity and pressure, bugs do as they damn well please. But chemistry normally works. Right, let's just move some bits and pieces out the way and we're ready to start. I've got here some potassium iodide and I've got some lead nitrate. I've got some water, and what I'm going to do is I'm going to make up a small amount of each of these in my really diddy little beakers, and we're going to see what happens to them when we do this. So I'm going to want only a small amount, and let's just get out a couple of spatulas and we'll make up some lead nitrate solution to start with. What is noticeable by this, it's basically a white solid, it is how heavy this weighs. And I'm going to take a small amount of there, I'm just going to put that in there. So this is my lead nitrate solution, and I'm just going to make it up with a little bit of water, and lead nitrate dissolves quite nicely in the water. We'll just give it a little bit of encouragement to try and help it go. There, it's just about dissolved. Okay, beautiful. let's do the same with the potassium iodide. Potassium iodide is a group 1 metal, so these are always white solids. I'll take a little bit of that in there, and we'll make up a solution to go with this. Well, I don't think I'm going to bother to stir that one. That one's beautifully dissolved. So I've got my 2 solutions, and what we're going to do is we're going to try out a little reaction of these 2. Now, I think I'll get out a small little beaker to put these in, because they're going to work better in a small beaker. I think I give it a little bit too small, so let's just put the lead in there. Right, so there we are. There's my lead nitrate, and let's put in some potassium iodide. You ready? Here we go. And that one, I'm sure you'll agree, has actually reacted, and we did get something occurring. When we look at this reaction that we've just done, that this stuff is bright yellow, and it's also a solid. And if I leave that for a few minutes, then the solid will settle to the bottom, and I can then retrieve it later by washing it and cleaning it, and I can collect some lead iodide. And lead iodide used to be used in paint, and there it is, my bright yellow, and you can see just at the bottom now, down here it is starting to come out of solution. It's already lighter at the top than it is at the bottom as the solid separates. So at least one of my experiments worked today, and I'm happy with. I hope you found some of this useful, looking at these displacement reactions. Next time we'll go on to having a look at extracting some metals, and we'll see if maybe we can try and get some salts from these metals. Take care. If you found it useful, please subscribe, and I'll see you next time. Bye bye.